Hi everyone. This is a continuation of log page 14, which is on the inverse trig functions, the inverse sine, inverse cosine, and inverse tangent. What you see in front of you here is the cosine function, y equals the cosine of x, and I hope that you will recall that from negative infinity to infinity is the domain of the cosine function. And the range of the cosine function is from -1 to 1 inclusive. Whoops, that should be a y, sorry. So that's the range. The domain, it starts at negative infinity, goes to infinity, keeps continuing this pattern forever and ever and ever. The range, the lowest point is -1. The highest point is 1. Is this function 1 to 1? Well, I can see from this horizontal line right here that if I put in a horizontal line anywhere from -1 to 1, that it's going to touch this graph in more than one place. So the horizontal line test tells me no, this function is not 1 to 1. Now from the video that you watched before, I hope that you remember that we can restrict the domain of the cosine function and make it 1 to 1 so that we can find an inverse. So we're going to restrict the domain for this cosine function, y equals the cosine of x. The restricted domain is going to be from 0 to pi. So the restricted domain for the inverse cosine function is from 0 to pi inclusive. 0 to pi inclusive. Well, is this function 1 to 1 now? If I drew a horizontal line anywhere on this function, you would see that it only touches in one place. So yes, it is now 1 to 1. All right, what is the inverse cosine? The inverse cosine of x, y equals the inverse cosine of x. That's how I read this. But it means that y is the angle whose cosine is x. Just like with the sine, when I have y equals the cosine inverse of x, the y is an angle and the x is the value of the sine. I'm sorry, of the cosine. We're talking about cosine here, not sine. So y is always an angle, and the x is the value of the cosine. So this is saying y is the angle whose cosine is x. So what I'm looking for here is an angle. Now, what I need you to remember is that with the cosine, this angle has to be within this restricted domain of 0 to pi. And the x has to be within -1 to 1 inclusive. All right, inverse functions undo each other. As long as we are in the restricted domain from 0 to pi inclusive, then the cosine of u, when it is input into the inverse function, they're going to undo each other, and we're just going to have u. So the cosine inverse of the cosine of u will always equal what I've started with, which is u, as long as u is in between 0 to pi inclusive. And likewise, the cosine of the cosine inverse of v is going to equal v. These two functions will undo each other, and I will end up with exactly what I started with as long as my v is between -1 and 1 inclusive. The characteristics of the cosine inverse of x. The domain of the cosine inverse of x is the range of y equals the cosine of x, and that would be between -1 and 1 inclusive. And the range of y equals the cosine inverse of x is the domain of y equals the cosine of x, which would be between 0 and pi inclusive. And this is because with an inverse function, you are interchanging x and y. Since you're interchanging x and y, the domain and range are interchanging as well. So the domain of the inverse is the range of the function, and the range of the inverse is the domain of the function. Here's my picture of y equals the cosine of x. That's the pink graph with its restricted domain. Starts at 0, 1, goes to pi halves 0, down to pi negative 1. This is my line y equals x. That's the identity function, which is acting as the mirror here. And then here is my inverse cosine, which is a reflection of the cosine of x across y equals x. Notice what's happening to the points. The point 0, 1 on the function, we're interchanging x and y. So it's going to be 1, 0 on the inverse. This point right here is the same on both functions. Okay, this point right here is the same on both functions. So if you're going to switch two numbers that are the same, it's going to stay the same. This point right here is pi halves 0, so it's going to switch to be 0 pi halves. This point is pi negative 1, so it's going to switch to negative 1 pi. Now, I'd like for you to think for a moment about this point right here and see if you can tell me what that point would be. What would be the coordinates of this point right here? Remember, we're talking about the cosine of x. And see what you can come up with that. Give that a little bit of thought, and we'll talk about that when I come back. All right, so let's find the exact values of, let me move this right here so you still have all your information. Let's find the exact value of y equals the cosine inverse of the square root of 3 over 2. The square root of 3 over 2. All right, the first thing I'm always going to do, like I told you with the sine, is replace my y with theta so that I don't forget that I am looking for an angle. So I just change y to theta so that I can look at it, and I tend to think of theta intuitively as an angle. So what we're looking for here is an angle theta. Now this time our restricted domain, remember, is between 0 and pi inclusive. So 0 to pi inclusive on my unit circle is going to be here to here. 0 to pi. Now the nice thing about the cosine is, unlike the sine, we're always going in a positive direction. So in quadrant 1, all of my trig functions are positive. In quadrant 2, the sine and its reciprocal are positive. And in quadrant 1 here, my angles will be positive. And in quadrant 2, my angles will be positive. So here I'm looking for positive angles all the way around. So now what I can do is I can say, well, I'm looking for an angle in quadrant 1 or 2 whose cosine is the square root of 3 over 2. Well, I know that the cosine is negative in quadrant 2, so I know I have to be over here in quadrant 1, and that would be the angle pi over 6. So pi over 6 is the angle whose cosine is the square root of 3 over 2. Okay, let's find the exact value of y equals the cosine inverse of the square root of 2, a negative square root of 2 over 2. Well, I know that the cosine is negative in quadrant 2, so I know I'm over here in quadrant 2. The cosine is the square root of 2 over 2, and so that tells me from my unit circle that I have to have a denominator of 4, because the denominators of 4 are the ones that have square root of 2 over 2 as a cosine. And I know in quadrant 2, the top number is 1 less than the bottom number, so that tells me 3 pi over 4 is my angle whose cosine is negative square root of 2 over 2. All right, now let's look at the tangent function. And I'm going to move this paper so that you can see, fresh, the tangent function. The tangent function, here are your asymptotes at negative pi halves and pi halves. This is your range.